Hello, so let's solve today's problem of the day. So today we are given with the problem minimum operations to make a uni-value grid. So firstly I will explain you the problem statement, then we will go through the intuition, and finally we will solve the problem using our C++ code. So let me firstly explain the problem. So what we are given in the problem is that we are given with a grid. We are given with a grid of dimensions n by m. Let's say this is a grid we are given with, and we are given values inside the cells of the grid like 2, 3, 4, 9, 7, 8, 8, 3, 7, 11, 12, 11, 13, 5, 12, 6, 7, 8 and 9. And also we are given an variable x, and we are given that we can add x or subtract s x from any element of the grid any number of times. For example, this 13 can be converted to 11, 9, 7 and so on, or you can convert 13 to 15, 17, 19, 21 and so on. So in this way we can generate different numbers at this place, and we are given this x that we have to add or subtract from the element. And this is asked to us that can we convert this grid into a unigrid. What is a unigrid? A unigrid is a grid which contains all of its cell having one element. For example, 2 2 2 2 2 2 2 2 2. This grid is called as a unigrid because all of its elements are same. So this is the problem statement. Can we convert the required grid into a grid which has all of its elements same? Let me take another example. So let us consider a 2 by 2 grid, 2, 4, 6 and 8, and we are given x as 2. So the first thing that we have to do is that can we convert this grid into a grid which is something like all of its elements here are same. And the second thing, we have to minimize the operations. We have to minimize the required number of operations. What happens in a single operation is that you select an element and subtract or add x to it. For example, in one operation you can change 2 to 0 or 4 or 6, not 6. In one operation you can only convert 2 to 0 or 4. In two operation you can convert 0 to 2 to minus 2 or 4 plus 2 yani 6. So this is it. The problem statement is this, and we have to minimize the operations. So let's come up with the intuition first, then after we will move to the solution. So the first thing that comes to our mind must be that is it possible to convert this grid every time into a unigrid? As the question statements ask us that if it is not possible for us to convert the grid into a unigrid, we should return -1. So let's first crack this thing that when we cannot convert our grid to a unigrid. So let's take two random elements from the grid. Let's say x and y. Not x and y because x has been already given to us. So let's take a and b. So now as we know that we can only add or subtract x multiples of x from a and multiples of x from b. So let's say both of them gets converted after subtracting or adding some multiple of x to some number alpha. Also in the same manner, after adding or subtracting some multiple of x into b, it gets converted into alpha. Because we have to convert the whole grid into a unigrid, all of its element must goes to some same element. Now for this scenario we had only considered a and b, so we can equate these two. Can you see something from here? Can you see something from here? uh, let's say in place of a and b, I replace them as some multiple of x and the remainder remaining. For example, written as a can be written as some multiple of x into some t3 plus remainder of a when divided by x. We can write it as this. Also, we can write b in the same manner, x into some multiple t4 plus the remainder b modulo x. When we put these two in this equation, what we get? Let us see. X t3 plus a modulo x plus x t1 equates to x t4 plus b modulo x plus minus x t2. Here it will be 2 2. Okay. Till now we have got this equation, and we have to come with some inference about when we can convert the grid into a unigrid and when we cannot. Can you say that if a modulo x and b modulo x are not same, then we cannot convert a to the same alpha as b? Can you see this? Can you say this? Let me represent it pictorially and graphically on a number line, then you will get it correctly. Let's say a is smaller than b, and we have a on the number line here and b on the number line as here, and you can definitely say that there will be some t3 into x here and t4 into x here, which is the closest, not the closest, but the left multiple of x closer to a and closer to b. So and we convert a and b to some alpha in here by adding some x or subtracting some x from a and b till alpha. Similarly from b till alpha. Can you say that if the initial gap is not the same, then we cannot convert a to that alpha and b to that alpha, because after this conversion we can always add x to both of the numbers, and we get alpha plus x as the next number, the next new alpha to which we can get a and b. If this initial gap, which is basically a modulo x and b modulo x here, if this initial gap is not same, we can definitely not get a to alpha and b to alpha by adding or subtracting x from them. We can see this from the pictorial representation and the graphical representation. So now, as you got the proof of when we cannot get the grid as a unigrid, is when we can find two elements with different remainder when divided by x. So as we have solved the first problem to us, that is when we can convert the grid to a unigrid and when we cannot. Now the next problem is that when we were be able to convert the grid into a unigrid, what will be the minimum number of operations, and how we can find that minimum number of operation. If you had ever read statistics, in statistics we have been told that for a series of numbers like a1, a2, a3, a4 and so on up to an, where a1 is less than or equal to a2, which is less than or equal to a3 and so on up till n, the minimum deviations about the median, the deviations about the median is minimum. Do you know this? That if we take the deviations, if we take the sum of the deviations, summation of deviations, sum of deviations about some x, and we call this as minimum deviation possible, for any x, then we can surely say that x must be a median. Why I am saying this? That if we can minimize the sum of the deviations, then the rest is, if we can minimize the deviation for some alpha, not the x, let's say for alpha, some alpha, from for some alpha to which we are going to convert the elements, to which we are going to convert the elements, this alpha, this alpha. Then if the sum of the divisions is minimum, then automatically the number of required operations will be minimum, because each of the total sum can be said as alpha minus a1 ka mod plus alpha minus a2 ka mod, and so on. So if the sum of the divisions are minimum, then definitely the number of operations required to convert the a1 to alpha, a2 to alpha, the sum of the operations will be minimum automatically. You can say this. So as I have completed with the proof, I will be explaining the problem solution with the code. So let us see the code. So let me now explain my code so that you can understand the problem very clearly. I am having a variable rem which stores the remainder of the numbers when divided by x, and I am having another vector so that I can find the median. I will store all of the elements of the grid into this array ARR, and I will find the middle element directly from there after sorting this array. Before then I need to store it. Let me store it from the grid by iterating through the grid. Now I will firstly store the number, and if the remainder is -1, basically this means that I have not iterated through the element and I have not gone through any single element. At this time I will just update my remainder as b modulo x. This represents the remainder which we will get by dividing the array elements by x, and the second element or the further elements which I will get while iterating, if they do not provide the same remainder as I have got previously, then I am definitely sure that I cannot convert this grid into a uni-grid, and I will return -1 from here. And if -1 has not been returned from here, then definitely I could have been converted this grid into uni-grid, and I will just store median into a variable val, and I will iterate through the array elements and just add the required number of operations to convert this C to val by adding absolute value of val minus x divided by x, and I will just return the answer from here. Also I have not defined the answer ans equals to 0. So here you can see I can get accepted by submitting the solution. I don't know why it is taking so much time. Sorry. What happens here? What happens here? What happens here? Why it is not minimum? Oh, I have not sorted the array. Sorry. Now we will get the right answer. Okay, so here it is. I will attach the proof of why it is the deviation about the median is minimum, and from there you can refer to the proof. I will attach the link into the description. So this is it. Thank you.